composite function. So right, so in derivative, this is the most important section. Even I can say this is the heart of the derivative. Once we know the composite function, we can easily tackle all the rest of the functions or rest of the types of the derivative. So right, it's very important to understand what exactly the composite functions in derivative are, how these composite functions forms, and how to take the derivative of such kind of composite functions. So be there friends, it's very important article from the derivative. Okay, so let me start with the basic thing. How a composite functions form. So I'm talking about how a composite function forms, means how its birth takes place. So right, so how exactly is the composite functions form? So see, we have a list of standard functions. So right, so I'm talking about standard functions. So let me list out few. So the first one, let's say we know from the trigonometry like sine x, then cos x, then tan x, then cot x, then sec x, and the last one is cosec x. So these are six trigonometric ratios, right? And these six trigonometric ratios are also a standard function. So in trigonometry we cover these six. Then even you can list out all the standard functions from algebra, like we can say root x, 1 by x, or x raised to n. So right, so these are also standard functions in our list. So it's a root x, 1 upon x, x raised to n. Then the third one, let me list out exponential and logarithmic cases. So see, in exponential it's a e raised to x, then a raised to x, then log x. See, there are list of functions available, but out of which I am taking few specific examples to understand this composite function. So this is the list of entire all six trigonometric ratios. So I am considering few algebraic functions also, like root x, 1 upon x, or x raised to n. Or let's consider few exponential and logarithmic cases like e raised to x, a raised to x, and log x. So I'm assuming these few examples and treat them as standard functions. So consider them as a standard functions, right? And let me tell you friends how exactly composite functions forms. See, while finding a composite function or while preparing a composite function, so what they usually used to do, they pick any standard function out of this. So let's say a sine x function. So let's consider a sine x function. This is y, or we can say a sine x function. Now what is a composite function? The composite function means we can merge one function with the another one, right? It's almost like a mixing two different functions. Try to understand this very basic concept. So it's almost like a mixing two different functions, right? So this is the sine x function, and they introduce one more function and combine with the sine x. Then sin is just a symbol, so they replace this x with any other function. So if I say this is sine, then they replace this x with any other function from this list. It may be anything. So let's consider this as a log x. So what is your observation, friend? So they replace this x using log x. So here you have to understand the one basic and very minor input here, which is in this sine of, see, sine x is a pure function. Try to understand this. Sine x is a pure function, but in this sine of log x, what do you think? Which one is a main standard function and which is replacing this x? See, sine x is the original function. Let's mark this as 1. And since this log x is replacing this x, so I am treating this log x as second function. So overall we can say sine x is a standard function, but sine of log x is a composite function. So right, so this sine of log x is a composite function. This is the way they form the composite function. So they replace x value from the standard function with any other function. And it is always better to express or number this kind of functions. So here sine is a first original function, and log x, which is a replacement for this x, treat it as a second function. There is a second layer of the function. So this is the first layer of the function, and this is the second layer of the function, and the sine of log x is called composite function of the sine and log. They start with any standard function in our list. So let's say it's e raised to x. They start with any standard function. Then from the standard function, they replace this x using any other function. Any other function from this list, or it may be anything else. So let's say it's a e raised to. Now they are replaced. Let's replace this x using, let's say, tan x. So friends, just try to observe how a composite function forms. So they replace this x from the standard function using any another function in our list, right? Okay, so then this e raised to tan x is called composite function. And what is important in composite function is specifying which one is the first and which one is the second. So here, if you observe, the main function is e raised to x. So main function is e raised to x. So I am marking this e as a original function. Always consider 1 for the original function, and the replacement for x is tan x. So I am considering this tan x as a replacement. So please mark this as 2. So as far as the sequence is concerned, exponential is the first function in the list, which was the original one, and the replacement for x is tan x. So please mark this as a 2. So friends, this e raised to tan x is called composite function here, right? So try to understand the sense how a composite function forms. Once we understand the sense behind the composite function, then and then only we can differentiate the given function. So always remember, this understanding of the formation of the composite function is very important. Here exactly most of the students makes mistake. Almost I can say 90% of the students make mistake in this particular example, where this is a case of x raised to n. So understand friends, this x raised to n is a standard function. X raised to n is the original function. N is a constant like x raised to 7, x raised to 5, x raised to 3. So this x raised to n is the original function, and let's say I am replacing this x by cos x. I am replacing this x using cos x. So this is a cos x raised to n. So it's like a cos x raised to n. So understand then which is the function, which is the first function. Most of the students make mistake. They consider cos x as a 1 and this power as a second. So no. So please understand this. This is the mistake. So cos x is not the original function here. The original function is x raised to n. So always remember, this x raised to n is the original function. So you have to treat this as a x raised to n, which is the original function, and cos x, which is the replacement for the x, you have to consider it as a second function. So right, so here this cos x acts as a second layer in this x raised to n case. I hope you are understanding this particular way of formation of the composite. So why I am giving us so much time on this particular case? Because I observed mostly 80% of students don't understand the derivative or makes mistakes in derivative only because of they don't know how a composite function forms or how to tackle a composite function. So let me tell you friends, you are not wasting your time, half hour or this 1 hour. I'm quite sure that once you understand how a composite function forms, then and then only we can take a derivative of the function. So it's very important. It's my request. This is very, very important to understand how a composite functions form. This looks very simple, but I observed 80% of students makes mistake in the derivative only because they don't know the way of formation of the composite function. So right. So it's my request, be there and please understand this thing very, very carefully. Okay, so let me explain you with one more example. If I say it's a y is equal to x raised to 7. So friends, this x raised to 7 is the original function which comes under this category x raised to n. So how they forms this composite function? So we try to understand they replace this x using any other function in this list. So let's say I am considering now a tan x. So we can say it's a tan x raised to 7, or let's say log x raised to 7. So understand this, they replace this x using log x. So it's a x raised to 7 is the case, and they replace this x using log x. So which one comes first? Log x or the 7? Log x or x raised to n? Which one comes first in the list? So x raised to 7, which is a x raised to n. So x raised to n as a first function, which is the original function, and the replacement for x is a log x. You have to treat it as the second one. The listing 1 or 2 is very important in composite function, because in composite function you have to analyze which is the original function and which is the replacement for the x. Always assign 1 to the original function, always assign 1 to the original function and 2 to the part which is replaced for the x. So this is the way that you have to number any composite function. Here sine is the first one and replacement for x is a log x, treated as a 2. So 1 is the original function and 2 is the replacement. So always I divide a composite function into 2 parts. I always divide a composite function into 2 parts. A original function and a composite part. Original function and a composite part. Important note about the composite function. About composite function. So, first one, if y equal to g of x is the given function. Y equal to g of x is the given function. This is the first function. Then, how they form a composite? They replace this x. They replace this x with any other function. So f of x. So this is the way that they form a composite function. So we read it as g of f of x. So this f of x is actually a replacement for this x. So this replacement for x is a f of x. So this y is equal to g of f of x is called a composite function, right? And in composite function you have to always specify 1 and 2. So tell me friends, what is 1 and what is 2 in composite function? So 1 means original function. See, this is the original function. So I am considering it as a 1. And a function which take a place or replacement for x. See, the replacement for x is a f of x. So treat it as second. So there are always 2 parts in the composite function. So we can say this 1 is a original function and this 2, which is the second part, is called replacement. So this 2 is called replacement. So right, this is the way that you have to understand any composite function. So composite function is actually a combination of the 2 parts. The first part is the original function and the second part is actually a replacement for the x, which is f of x in this case. So always mark a composite function as a 1 and 2. There are 2 parts involved in composite function. So let me explain you this thing with one example. So if I say y is equal to sine of log x, that we already discussed. So here the original function is sine x and this log x is actually a replacement. So original function is sine x. If you remember, original function is sine x and the replacement for x is log x. So sine is the first part and log x is a replacement, which you have to assign as a 2. So then one more example on this. Let's say it's a y is equal to it's a log of 5 raised to x or log of I'm considering as tan x. So let me start with a simple example. So this is log of tan x. Understand the original function is log x. So the original function is log x. So log is the first part or the standard function and this tan x is actually a replacement for this x. So we can assign 2 number to the tan x, and derivative depends on this numbering. So log x is the first part and tan x is the replacement, which is the second part for this composite function. So next, one more example. So please write down, friends, one more example for this. Then the third case, if I say it's a y is equal to under root 5 raised to x, or let's say 7 raised to x, or we can say y is equal to under root, let's say sec x. So which is the original function here? So understand, the original function is root x. Original function or the standard function is root x, and this root is the first one and the replacement for x is sec x. So let's assign 1 to this root and sec x as second part. So root is the first and sec x is second. So let me explain you the fourth one, where exactly the students makes a huge mistakes. So what if it is sine raised to tan x? This is the mistake. This is the problem where I found students makes mistake. Most of the time 80 to 90% students make mistake in judging this particular question. It's a sine raised to tan x. So friends, it's a sine raised to tan x. Maths is a symbolic language. So actually this representation you can work in this way also. It's a sine x total raised to 10. So if you want, you can write this sine raised to 10x as sine x raised to 10 also, right? Then which one is the first function, or which one is the original function? If you understand, this x raised to n is the original function. So this x is hidden, which is x raised to 10 is the original function, and the replacement for x is sine x, that you have to treat it as a 2. This is something different, so you have to mark this as very offbeat case. Always remember here, sine x is not a first one, sine x is not a first one. Here the first thing is x raised to n. So x raised to n is the first, or x raised to 10 is the first or the standard function, and the replacement for x is a sine x. You have to treat it as the second one in composite list. So here I am talking about x raised to 10 is, so read it as x raised to 10 is the first one, and the sine x, which is a replacement, you have to treat it as second. One more, what if it is sine of x raised to 10? See, these two things looks very close to each other. So these two things, this is actually a point where students get confused. So these two things looks very close to each other, but they are different in composite. So understand, friends, then which one is the first and the second here? See, this index 10 is not actually a power of sine. It's actually an index of this x. So here the original function is sine x. So original function is sine x. So treat this sine as a first and this x raised to 10 as a second part. See, it's my request, closely observe these two particular cases. There is a huge difference between sine x raised to 10 and sine of x raised to 10. So actually this index belongs to this sine x, but here this index 10 is only assigned to this x. So there is a huge difference between the case number 4 and case number 5. In case number 4, x raised to 10 is the first function and sine x is a second. While here, if you observe, in this case, this index 10 belongs to this x. So originally sine x is the function. So sine is the original and replacement for x is x raised to 10. So please assign 2 to the second part. So whatever we discussed up to this point is the way of formation of the composite function. So friends, I hope you got at least a somewhat idea how a composite function forms. So it is not there in any textbook how exactly a composite function forms, but I hope you understood this concept of formation of the composite function with few examples, and always remember marking 1 and 2 is very easy way of tackling this composite function. So right, so please understand this particular thing. if this is the original function, then this is the composite function, and in composite function, it is very important to assign the original function as a 1 and the replacement for x as the part 2. So there are only two things involved in the composite, first part and second part. Okay, up to this particular point, we talked about how a composite functions forms. How a composite functions form. So friends, then let me tell you the next thing, how to take a derivative of the composite function. So the first thing is, let's say this is the composite function. So y is equal to, let's say g of f of x is a composite function. So we already know this is the way that we represent a composite function. Y equal to g of f of x. I am assuming this g is a original function, assign it as a 1. Then this f of x is, let's say, the second function, which is always a replacement for the x. So original function is g of x, and this f of x is the replacement for x, so I am assuming it as a 2. So while taking a derivative, or while differentiating this derivative of y with respect to x, means differentiating this g of f of x. So right, so differentiating the left hand side with respect to x, then I am also differentiating the right hand side with respect to x. So we can say this is the symbol for the derivative. So read it as derivative with respect to x. So read it as derivative with respect to x. So this is the derivative with respect to x of LHS. Then this is derivative with respect to x of RHS. Means we are differentiating both LHS and RHS. Okay. Then the rule is quite simple. You have to always express the derivative of the first part into derivative of second part. So always remember, you have to differentiate this into two parts. You have to always differentiate first part as g of f of x into derivative of second part separately as derivative of f of x. So I will explain you how exactly you have to apply the derivative with one example, but write down. So the way of finding a derivative is quite simple. Just differentiate derivative of first part into derivative of second part, which is also called the chain rule in the derivative. So here you have to differentiate derivative of first into derivative of second. See, the way of finding a derivative is quite simple. It's a derivative of first part into derivative of second part. So let me explain you this thing with one example, which we already discussed. So y is equal to sine of log x. So friends, let's understand the derivative of this composite using this one simple example. Let's say it's a y is equal to sine of log x. So please assign 1 and 2 to the composite function first. So tell me which is the first and which one is the second. So original function, if you understand, original function is sine x. So friends, original function is sine x. So sine is the original function, so I am marking this sine as a 1. And who takes the place for the x, or the replacement for x? See, the replacement for x is a log x. So please assign this log x as a second part. So log x is a second part of this composite. So sine is the first and log x is the second. Now let's try to differentiate this one. So derivative, this is the symbol for the derivative, d by dx. So d by dx, don't read it as a d by dx. So please write down it as derivative with respect to x. So read it in this way, it's a derivative with respect to x. So it's a derivative with respect to x of LHS, then derivative with respect to x of RHS, which is a sine of log x, right? So this is just a way of representing the things. So this is the derivative of LHS and this is the derivative of RHS. You can read this particular thing in this way. It's a derivative of LHS and the derivative of RHS. So if you observe, here sine is the first part and this log x is the second part. And the way of finding the derivative is derivative of first into derivative of second. This is the way that you have to differentiate. So derivative of first into derivative of second. So let me take differentiation of this. For that, Let's assume this two part, second part as x temporarily in your mind. Assume this log x as x. Then it's almost like taking a derivative of sine x. So derivative of sine x. So let me write down. It's a derivative of first part into derivative of second part. See, try to understand this way of differentiating the composite function. So while taking a derivative of composite function, differentiate the first part of the composite function into differentiation of the second part of the composite function. So here I am differentiating the first function into derivative of the second function, which is log x. Now how to tackle this particular thing? To understand or to find the derivative of sine of log x, first of all, try to understand what was the derivative of sine x. What was the derivative? In previous lecture, we listed out all the standard derivatives. So tell me friends, what was the derivative of sine x? So derivative of sine x is cos x. We know this formula. Derivative of sine x is cos x, right? But here if you observe in the standard formula, there is a x present. So we can say derivative of sine x is cos x. Then what is the derivative of sine? Assume this as the x. So what is the derivative of sine x? Derivative of sine x is cos x. Then derivative of sine of log x is cos of log x. See, try to understand. Derivative of sine x is cos x. Then the derivative of this sine of log x is cos of log x. I am using this standard formula. Derivative of sine x is cos x. Then into what is the derivative of log x, which is also a standard formula if you remember. Derivative of log x is 1 by x. Then the derivative of this log x is 1 by x. That's all friends. Here we got the derivative of this composite sine of log x. Try to understand this entire process, which is very simple, just because you know how a composite functions form. Then and then only you can understand this process of a composite function. So first thing is, this is the given composite function. Your first task is to assign 1 and 2, or I can say original function and the replacement for x. So here in this example, sine is the original function and this log x is a replacement for x. So sine is the original, sine log x is a replacement for x. So this is a 1, this is a 2. Then how to tackle or how to find the derivative of composite? So process is simple. Derivative of first into derivative of second. So always remember this one. To tackle a composite function, the process is called chain rule, which is very simple. It's a derivative of first part into derivative of second part. So if you want, you can remember in this way. It's a derivative of first part into derivative of second part. So observe this one. It's almost like I am taking the derivative of first part into derivative of second part. So if you observe, this is the derivative of first part into derivative of second part. So what you have to remember in composite function is, while taking the derivative, always take derivative as derivative of first part into derivative of second part. This is the way that you have to tackle. So it's a derivative of first part into derivative of second part. Now, while tackling this derivative of first part, sine of log x, try to recall a standard function. Derivative of sine x is cos x. So derivative of sine of log x is cos of log x. Then the second part, derivative of log x, which is a standard function. So derivative of log x is 1 by x. So that's all. This is the derivative of this composite function sine of log x. I hope. Let's see the next example, which is y is equal to log of sine x. Okay, before taking the derivative, first of all assign 1 and 2. So let's assign 1 and 2, which is the original function. See, understand friends, original function is log x. Original function is log x. So assign 1 to this log. Let's assign 1 to this log because original function is log x. And what is the replacement for the x? Who takes the place value of this x? So replacement for x is sine x. So whatever is the replacement for x, that you have to assign it as a 2. So this is the way that you have to number into a composite function. So understand, log x is the original function. Log x is the original function and replacement for the x is actually sine x. So here I'm assigning 1 to the original function log, and I'm assigning 2 to the second function, which is a replacement for this x is a sine x. So mark it as 2. And the process of finding the derivative of composite function is quite simple. Just you have to differentiate in this way. Derivative of first part into derivative of second part. This is such a simple process of finding the derivative. Always remember, it's all about finding derivative of first part into derivative of second part. So okay, let's start differentiating this sine of log x. So I'm differentiating LHS. See, this is the symbol of the derivative. Understand, friends? Every process has its symbol, and maths is the symbolic language. So you have to understand, this is the symbol for the derivative. Don't read it as d by dx. No, it is called a derivative with respect to x. Or this is the way that you have to read. It's a derivative with respect to x. So it's a derivative with respect to x of LHS, then derivative with respect to x of RHS, which is log of sine x. Then we already assigned 1 and 2 to these functions. Here the log is first and sine x is the second, and the process is quite simple. It is all about finding the derivative of first into derivative of second. So it's a derivative of first into derivative of second. Are you getting this point? So it's very, very easy. It's all about finding the derivative of first. See, understand this thing. So it is all about finding. This is a very important step. It's all about how to find the derivative of LHS. It's a derivative of first into derivative of second part. Derivative of first part into derivative of second part. So it's a derivative of first part along with this log of sine x into derivative of the second part. Okay. Then tell me, what is the derivative of a standard function log x? So derivative of log x that we already know is 1 upon x. Please go and check the yesterday's or the previous lecture's standard result. So we already listed out all the standard formulas in previous lecture. Please refer that previous lecture and please revise all the standard derivatives. We already know the derivative of log x is 1 by x. So the derivative of log treated as a x. So understand, friends? So this x. So log x, derivative of log x is 1 by x. So derivative of log of sine x is 1 by sine x. This is the way that you have to read it. So it's almost like a derivative of log x is 1 by x. Read it as derivative of log treated as x. So log x derivative is 1 by x. So this is the derivative of first part, and what is the derivative of second part? You know, this is also a standard function. So derivative of sine x is cos x. So derivative of sine x is cos x. So what is the derivative of this sine x is cos x. Here we got the final answer for this problem there. This dy by dx is cos x divided by sine x, and you know that cos x by sine x is cot x. So cot x is final answer as a derivative of this composite function. So I hope you understood this exactly, the concept of the finding the derivative of the composite function. It's very, very simple process. Assign 1 and 2. 1 to the first part, 2 to the second part, or 1 to the original function, 2 to the replacement for the x. So assign 1 and 2, and finding the derivative is quite simple. It's a derivative of 1 into derivative of 2. So right, so I hope you got this concept of this composite function and finding the derivatives of this composite function. Solve this next question. So I hope you got this concept and you can easily solve this next example. What if it is y equal to under root sine x, or let's say y equal to under root tan x. Let's try to find the derivative of under root tan x. Derivative of under root tan x. Okay, so friends, your job is to find which is the original function here. So try to first of all guess the original function 1 and then the replacement. So here the original function is root x. The original function is root x. Understand this? Root x is a original function. And I am assigning this root as a first part of the composite. And if you observe, the replacement for x is tan x. So the replacement for x is tan x. So please assign this tan x as a second part of the composite. So I am assigning this tan x as a second part of the composite. This is all about understanding which is the original function and which is the replacement. So original function is a root, and x, the replacement for x is tan x. So always assign 1 to the original part and 2 to the replacement for the x. So here we got 1 and 2, and we are finding the derivative is quite simple. Derivative of first part into derivative of second part is the way of tackling a composite function. So let's start with simple differentiation. So friends, this is the symbol for the derivative. So read it as derivative, or simply derivative with respect to x of LHS, then derivative with respect to x of RHS. So this is the derivative of left, and this is left hand side, and this is the derivative of right hand side. Okay, so here root is the first one and this tan x is the second part. So right, so this tan x is the second, root is the first. Then tell me, what is the derivative of root x, which is a standard derivative. I hope all of you remember standard derivative list. So I hope in previous lecture we already listed out all the standard derivatives, and I expect you recall this particular formulas to tackle this composite. What was the derivative of root x? So derivative of root x is 1 upon 2 root x. Derivative of root x is 1 upon 2 root x. So right. So let's apply it over here. So for the sake of simplicity, I am assuming this as x. Temporarily, if you want, you can assume the second part as x. So treat it as a x temporarily in your mind. So consider this tan x as a x. So read it as derivative of root x is 1 upon 2 root x. So I am considering this tan x as a x. So friends, understanding this way, it's a derivative of root x, right? So what is the way of finding a derivative in composite function is derivative of first part into derivative of second part. So understand this is very important process. So finding a derivative of composite is all about finding a derivative of first part into derivative of second part, which is also called the chain rule in composite function. Okay, then next. Derivative of root x is 1 upon 2 root x. Derivative of root x is 1 upon 2 root x. So I am treating this as a x temporarily, assume this as a x. So read it, derivative of root x. So derivative of root x is 1 upon 2 root x. So here I applied this particular formula to find this derivative. So derivative of root x is 1 upon 2 root x. So derivative of root tan x is 1 upon 2 root tan x. And the second standard formula, if you remember, the derivative of tan x is sec square x. Derivative of tan x is sec square x. So this derivative of tan x is sec square x. So that's all friends. Here we got the derivative of this composite function under root tan x. I hope in this particular session you got a slight idea about how a composite function forms. See, the main motive behind this particular lecture, or from this lecture we have to understand these two particular things. The main conclusion, so we can say it's a conclusion of this lecture with two important things. The first one, in order to tackle a composite function, you must know how a composite function forms. Your job is to understand how a composite function forms. This is the first thing. And the second thing is how to tackle a composite function. So to tackle a composite function, always give a numbering 1 and 2, and the way of finding a derivative is quite simple. Just differentiation of one first part into differentiation of the second part. This is the way that you have to tackle a composite. So this is not the end of this composite part. This was not just the introduction. This was not just it was all about how a composite function forms and how to take a derivative of this composite function. But in next session, definitely we will cover in detail way of tackling this composite function. So please don't miss the next very important lecture on composite function. I hope this today's lecture give you a certain idea about how a composite function forms and how to tackle derivative of the composite function. If you really liked it, please don't forget to like this YouTube session, and please share with your friends also. Please subscribe this channel. Thank you friends. Thanks for joining this today's YouTube live session on introductory part. Let me tell you, this one was a small introductory part of the composite. In next lecture, we will see how to solve deeper and deeper composite functions. Right? So please don't miss the next session on composite function. Thank you friends. Thanks for joining this YouTube live session on the composite function. So till the next lecture, take care, goodbye. I am signing off, and don't forget to like this live session. Thank you friends.